You, you heard that recording is now in progress, and what's being recorded? Just the screen. You're not there. So we are working on the inverse functions. What is an inverse of a function? Whenever you have a function, you need to perform some specific actions. Like in this case over here that we are looking at now, you have one function which is defined by x minus 2y equals a 5. You see the yellow highlighted one? X minus 2y equals a 5 is a function. Now we're not sure that which of the variables here is being defined by which one. I can write this function in two ways. Let's look at this. If I have here x minus 2y equals a 5, this one, I can subtract from both sides a 2y. From both sides, if I will subtract a 2y, oh, not subtract, because I will always be going with the inverse operation. If I see the addition, I will use the inverse of addition. What's the inverse of addition? Addition and subtraction are the opposites for each other. Multiplication and divisions, these are the opposites to each other. So if I see that 2y is being subtracted here, what will I do? I will add 2y on both sides, and that will give me the new form of a function, which is x equals 2y plus 5. 5 was already there. I didn't change anything into that. So x equals 2y by 5. This is one type or one way of writing it. We can do the same thing with the y also. I can separate the y as well. How will I do that? Now let's do that set of steps. How? Look at this. Now we'll write the same function again. X minus 2y equals 5. And now instead of subtracting, like adding 2y, we can proceed in this way. Look at this. I will be subtracting x on both sides. X was being added over there, so I subtracted x on both sides. Make sense? What will that give me? On the left hand side, here, x is gone. Plus x minus x will be a 0. So that's gone. What am I left with on the left hand side? Negative 2y equals 5 minus x. Agreed? Negative 2y equals 5 minus x. Now I want to separate the y from here. I want to separate the y. What additional step is required to make y alone? Nothing should be there with the y. Add. Okay. Let's first of all figure out what's the operation between 2 and 1. Multiplication. And what's the inverse of the multiplication when I'm looking at the operations? Divide. So what should I do over there? I should divide. Divide by what? Negative 2. So I will divide by negative 2 on both sides, which will give me alone y. Negative 2 divided on both sides. And what did I get? I will try to bring it over here. I will get a y equals 5 by 2 with a negative sign. I'm distributing the division on both the numbers. So negative 5 by 2 and plus x by 2. Make sense? What do you think? Make sense or not? Everyone? Okay. Does it make sense? Y equals this. Now using this, I have done, in fact, separately just writing the function y equal in terms of x. We have not yet discussed the inverse of a function. We will go for that. And I will be discussing the inverse of a function in three forms with you. First of all, in a table, then the ordered pairs, and then in the function itself. Then why did I do this? Because here, the first step in your worksheet is telling you, sketch the line x minus 2y equals 5. And that's what we will do in a few minutes. And then, and complete the table of values for the function. So let's sketch the function first. I have separately given you 2 points. How to rearrange a function in different ways. Now let's sketch it also. Here, I'm trying to sketch it. Hello. Where should I sketch it? Desmos? Yep. I'm opening the Desmos here. TTSMOS. Okay. And Desmos graphing calculator. Let's sketch the function. And what was the function? X minus 2y equals a 5. You see the function? It's there already. Now, what are we supposed to do from this sketch? We are supposed to find from here the values for y at different points of x. Do you know how can you find the value of y against the value of x from the graph? So, we have the plot here. What do I need to do? I need to find the value of x at x when x is, sorry, value of y when x is 6. So I move the cursor on the line. I move the cursor on the line, and then I noticed when x was a negative 6, y is what? What's the y when x is negative 6?
Minus 5.5.
Exactly, negative 5.5. So that's the value which I will bring over here in the table. Let's do it. And can you do it yourself also in Desmos? Try it now. So we have here negative 5.5 as a value of y. Good job, sir. That's what you should do. By sketching a plot easily, you can definitely figure out what is the value of y from the value of x. So next thing, we will create all the values. We'll try to find out all the values. For negative 6, we got a 5.5. What do you think is the value for negative 3? Can you tell me? From your plots, if you have done it in Desmos, tell me what should be the value for negative 3. When x is negative 3, what is y? Kiwi? What's the value of y when x is negative 3? You can switch to Desmos on your computer. Open Desmos.
Huh?
Now, we have the x negative 6, and we did find out that the value for y for negative 6 is negative 5.5. Now what we will do, for the value when x was negative 3, what's the value of y? Can someone help me on that? What's the value of y for x negative 3? Negative 4, thank you. So I'm putting there a negative 4, and somehow my pencil it should be back soon. Enough. And what's the value for x0? Negative 2.5, thank you. So for negative 3, it was negative 4. For 0, it was negative 2.5. And for 1, negative 2. Good. Did I do some mistake? Let me correct it. 2.5, is that right? 2.5. Now, you know what are we going to do now? we created a new table of values, create a new table of values. How do we do that? We have done the first step, we sketched the plot, we completed the first table. Now, what I am going to do, look at this. I will first name, in addition to something that table is telling me, the sheet is telling me, I'm naming the first table as f of x. It's a function that turns the values of x to y. Now, what I'm going to do, I will switch the values of x and y. I will keep the x here. I will keep the y here. But what's happening now? Look at this carefully. Don't miss this part. I will bring in the values of y in the place of x. What's the next value? -4. What's the next value? -2.5. And what is the next value? -2. Then I will bring in the values for x. Then I will bring in the values for x, and I will place those values in the column y. I will place those values in the column y. So y is -6 now. Is it difficult? What did I do? I just switched the x and y. With this simple operation, this function is now inverse function. I will name it f raised to power -1 of x. And we call this f inverse of x. So what did we do here? Look at this portion only. We switched the values of x and y within each other. The values of x are now the values of y. The values of x are the values of y. And the other one switched with each other. That's how we will create the inverse of a function in terms of tables. Make sense? Difficult? No? We can do that, huh? Easy thing. So in the table, it's really easy. Now I will hold it here for just 1 minute. I will hold it here and I will jump to the other sheet because I have told you how to find inverse of a function when you have tables. First thing done, you have a function to the left side table and you are trying to figure out what is the inverse of a function. Just switch the values of x and y. Whatever was an x, make it a y. Whatever was a y, make it an x. You got the inverse. Got it? Second thing, when you have the ordered pairs, and where do I have the ordered pairs here? In this worksheet, you see on the first one, first 6 questions. First 6 questions, let's switch to this for just 1 minute. Let's switch to this, and I'm sure that you will easily figure out how to find the inverse if you have ordered pairs. Now, how many pairs are there in question number 1? 3, and each of those is x and y. Agree? The first coordinates are always x and the second coordinates are always y. What are we trying to do? If I'm considering that these all are f of x, we are trying to figure out what's the inverse relation to now. Pay attention. Pay attention. Here, we have the ordered pairs, x and y, and we are trying to figure out the inverse. You know what to do, Mackenzie? Ordered pair, x and y. We are trying to figure out its inverse. I will switch the positions. How will I write it down? I will write it down. Damien, pay attention here. I will write it down like this. The same ordered pairs. I will write down the 3 ordered pairs, and I will call that set f inverse of x. F inverse, I will call it. And what to do? I will simply switch the x and y, 1 and 3. Did you notice what did I do? I changed the 3 and 1 to 1 and 3, and we are done. That's it. Inverse of a function when you have the pairs. So what's the second pair? Say -3 and 4. What's the third pair? -3 and 8. Isn't it the easiest work in math that you have ever done? Just switch it. It's easier than even 2 plus 2. In 2 plus 2 also you will have to think. Here,
Yes.
it's just a switch. Switch the ordered pairs and you found the inverse. So we did with the table. How will you do it? Switch the x and y. We did now the second type of inverse. We change the x and y coordinates in an ordered pair and we are done. 2 things done. Now, third and the last thing, I'm giving you a hint now for the function. When you have a function and you're trying to figure out its inverse, how will you do that? Look at this. I will show you this in an example of the question number 12 here. Question number 12. Don't worry, I'm just trying to bring it in from different slides so that we will touch all the ways of working to find the inverse, and then we will practice also. Here now, last thing that I need to discuss with you. Here, we will work in the steps. You see on that board, on the top right corner, I have mentioned finding inverse in 3 steps. What's the step number 1 over there? Step number 1 over here, and that step number 1 I'm gonna bring in here. The step number 1 is telling me if you have an f of x, change that to a y. Do we have an f of x in question number 12? We don't have it. It's already a y, so nothing to change. Agreed? What's the step number 2 over there? Step number 2 is telling me switch x and y with each other. Damien, step number 2, we're gonna switch the x and y. Look at this. How will I switch in question number 12? The x and y, wherever I will see an x, I will replace that with a y. So in question number 12, this y is going to change to an x. So x equals the y. I will change that y to an x. We had a y, I changed that to an x, and wherever I saw an x, I will change that to a y. So this x that was there, I'm going to change that to a y. Is it not again a switching? Switching between x and y. And then I will do one thing. Let's first complete the whole expression. The whole expression completed by switching. Third step, solve it for y. And we are done. Third step, solve it for y. And what do we mean by solving it for y? We will separate the y on one side. First thing, inverse of an addition is subtraction. So I will do a subtraction of 2 on both sides. That will give me this step. What else do I need to do to separate the y? I can multiply it with a 3 and divide it by a 2. Because 2 is being multiplied here. So I will divide it with that. 3 is being divided here, so I will multiply it with that. Switch these things on both sides. So what I will do, I will multiply it with this on both sides. 3 by 2. Make sense? Here, the 3 and 2 are cancelled out. What am I left with on the right hand side? I'm left with a y equals 3 by 2, x minus 2. And this function here is now the inverse function of x. That's what we will call it. Once you're done with the switching in the 3 steps, at the end, call this y, you can call this y f inverse of x. That's it. Just renaming it, nothing more than that. We have the inverse function, that is the inverse function. Make sense?